Hello everyone, welcome back to Philos Academy. In today's video, we're going to take the introductory part of business statistics. So without wasting much time, let's start. Now we're going to start by looking at the definition of statistics. Now as a word, statistics is actually a term used to indicate a group of numbers or collections of numerical data. So when you are able to state the average starting salary of college graduates is statistics. Or when you state the number of theft cases on campus in the year 2022 is also what? Statistics. Okay. So when you state the number of active COVID cases, okay, maybe on campus is also statistics. But statistics as a subject is a science that studies the methods and procedures for collecting, organizing, presenting, analyzing and interpreting numerical data to assist in making more effective decisions and for other useful purposes. So the keywords there are underlined, and also make sure you are able to say it's a science. Okay, so let's say you have a company and then you produce soap. You want to know the general public view about your soap, the soap you produce, okay? And then you run a sample of 100 individuals and then ask them if the soap is good or not. The responses you are getting from them are the data that you are collecting. So that's why the keyword they're collecting, okay? But later you need to organize it and then study it properly. Now let's say 70 of them responded that it is good and then 30 responded that it's not good. Now when you convert your data to percentages, it means that 70% of your sample of 100 said the soap is good, and then 30% said it's not good, isn't it? So if 30% said it's not good, you can infer that 30% of the general public think your soap is not good. So you can go and improve on the quality of your soap so that that percentage can reduce. Maybe you can reduce to 10%. So with the help of statistics, you are able to make effective decisions. You see that? The aim of statistics is to teach you how to collect data, organize it, present it properly, and then analyze the data and interpret it well. Now, why study statistics? We study statistics for the purposes of decision making in the processes below. To determine whether the existing information is adequate or additional information is required. Okay. And also to gather additional information if it is needed in such a way that it does not provide misleading results. When I took a sample of 100, I can decide to go back and then get another sample of 100, question them to see the proportion who think the soap is good or not. Also, to summarize the information in a useful and informative manner. When you collect data, you should be able to summarize your data in a useful manner. So with the help of statistics, you'll be able to do that properly. And also, to analyze the available information. With the help of statistics, you'll be able to know how to analyze the information that you have properly. That's why you are studying statistics. So with the help of statistics, you can conclude and also make proper inference. Now in summary, we study statistics because data is everywhere. Every day we have data, okay? And also, statistical techniques are used to make many decisions that affect our lives and that of others. For instance, sometimes when you go to Play Store or App Store to download an app, some of you check the ratings, you even check the number of downloads. When you type AIM app right now, maybe you can see maybe 10 AIM apps over there or 5 AIM apps. But for you to know the original one, sometimes you check the number of downloads. The one that has the highest download, you select that one, isn't it? So you see that you've been able to use statistics, numerical information to make effective decision. And also, no matter what your future line of work is, you definitely make decisions that involve data. Okay, so that's another reason you study statistics. So let's look at some of the terminologies that we use in statistics. So the first one is population. Now, population is simply the complete set of data being studied. So in other words, it is a collection of all possible individuals, objects or measurement of specific interest. To infer something about a population, we usually take sample from the population. You should know that. Let's say you are interested in knowing the average income of farmers in Ghana. So the population is not the whole Ghana, no. The population becomes the total number of farmers in Ghana. Let's say you are interested in knowing the average income of carpenters in Ghana. The entire Ghana is not the population at that moment. All carpenters in Ghana becomes the population of interest. And then sample is a subset of a population, or we say it's a portion or part of the population of interest. So you should be very careful about that. So sample is a subset of a population. In other words, it is a portion or part of the population of interest. Now, I said earlier that to infer something about a population, we usually take a sample from the population. You know that you can't get all carpenters in Ghana. You can't get all of them, isn't it? So you are going to take a sample of them and then ask them of their what? Of their daily income. Now when you ask them of their income, then you find the average. Then you infer, okay, you use it to speak about the entire population that, okay, the average income of what? Carpenters in Ghana per day is, let's say, 50 Ghana cedis. Because you can't get the entire population. That's not easy. Okay, so we usually take samples so that we can infer something about the entire population of interest. So let's look at another terminology known as what? Data set. It is a collection of all data values. Okay, so each value in a data set is called data value. And then the entities on which data are collected is known as elements or units. Okay, then another term is observation, the set of measurements obtained a particular element. And another term is sample survey, a survey to collect data on a sample. Okay, and then census is a survey to collect data on the entire population. So you should know the difference between sample survey and then census. And then random variables. Now, variables whose values are determined by chance is known as random variable. That's why the word random. Okay, something that occurs by chance, that happens by chance, is random. So when we say random variables, they are variables whose values are determined by chance. Now let's look at the types of statistics or branches of statistics. The first one is known as descriptive statistics. Descriptive statistics is concerned with the description, presentation, and summarization of a set of data in an informative way. So when you ask the general public if your soap is good or not, okay, 70% said it is good and 30% said it is not good. So that presentation you've made over there is known as descriptive statistics. Okay, and then the second branch is inferential statistics, also known as inductive statistics. This one is concerned about drawing conclusions. Okay, and when you also make predictions into the future. Okay, when you draw conclusions regarding a population of interest on the basis of a small part of the information. So for instance, let's say of the sample of 100 individuals that you took, 70% said your soap is good. Now then you use the sample information to judge the entire population that 70% of the public think your soap is good. You didn't use the entire population, you only took a sample of 100, but from that sample of 100, 70% said your soap is good. Then you conclude that 70% of the population think your soap is good. That is inferential statistics. Okay, that's why on the basis of a small part of that information, that is the sample. Let's look at what is meant by variables. Okay, a variable is a characteristic or attribute that can assume any of a prescribed set of values, called a domain of a variable. So gender is a variable because gender can be a male or a female. Religious preference is a variable because religious preference can be Christian, Muslim, traditionalist, or anything. Okay, now we have two types of variables. Okay, and one is known as qualitative variable and the other one is known as what? Quantitative variable. Qualitative variable is also known as categorical variable, and then quantitative variable is also known as numerical variable. So let's look at their meanings. Now, qualitative variable, also called attributes, are non-numeric. They are not in numbers. Okay, they are variables that can be placed into distinct categories according to some characteristic or attribute. For instance, when I ask you of your sex or gender, it's either you tell me you are a male or a female. Your gender is not in numbers like 2, 5, 7, no. And they can be placed into distinct categories. Okay, so the variable gender is what? Is qualitative. When I ask you of your religious preference, it's either you tell me Muslim, Christian, or traditionalist, isn't it? So you see that it can be placed into distinct categories as well. And they are not in numbers, hence religious preference is what? Qualitative variable. Now, the second one, which is quantitative variables, are numerical in nature and can be ordered or ranked. You can order them or you can rank them. But when you go to qualitative variables, you can't easily what? Rank them. You can't tell me male is ahead of female or female is ahead of male. No. Okay. But for quantitative variables, you can order them. You all know that 5 is more than 3. Okay. So the variable age is numerical. Okay. And individuals can be ranked in order according to the value of their words, of their ages. So when you have 25 years, 23 years, and 21 years, we all know that what? 25 is more than 23 and 23 is more than 21. So we can rank them. Okay. But quantitative variables can be classified into two groups, namely discrete variable and continuous variable. So let's look at what they mean. Now when we talk about discrete variables, they can be assigned values such as 0, 1, 2, 3. They are countable. So examples of discrete variables are the number of children in your family. Okay, you can count them. Okay, discrete variables are countable. Or the number of pizza sold by Pizza Man a day is also discrete variable because you can count it. Okay, or the number of students in your class, you can count them. They are countable, hence it's also discrete variable. Or the number of cars that pass through a checkpoint is also countable, so it's a discrete variable. Okay. Then when we talk about continuous variables, they can assume all values between any two specific values. So let's take temperature. Temperature is a continuous variable. Okay. Since the variable can assume all values between any two given temperatures. So other examples are weight of individuals, length of items measured in centimeter, kilometers, and etc. Okay. For continuous variable, we can't easily count them. We actually measure them. So when you want to know the length of something, do you count the length? No, you measure, isn't it? When you want to know the weight of an individual, do you count the person's weight? No, you measure it as well. So mostly continuous variables are measured, they are not counted. So this will lead us to something we call levels of measurement. Data are the facts and figures collected, analyzed and summarized for presentation and interpretation. So data can be classified according to levels of measurement. Now, measurement is the process of mapping or assigning numbers to objects or observations. So measurement can be in common units like meters, in cedis, in naira, in liters, grams, or number of persons. Or scores assigned to object quantities that represent a rating. Now, actually, there are 4 levels of measurement. The first one is nominal level of measurement. The second one is ordinal level of measurement, interval level of measurement, and ratio level of measurement. The oldest one among them is the nominal level of measurement. So in exams, you can be asked, which of the following is the oldest level of measurement? Or which of the following is the most primitive level of measurement? It is the nominal level of what? Measurement. But let's take them one after the other. So the first one we're going to look at is nominal level of measurement. In the nominal level of measurement, the observation can only be classified or counted. You can only classify the observations. So yes or no. Okay. The nominal scale defines specific categories by name, number, or symbol. So nominal scales indicate group membership. So there is no particular order to the labels. Okay, so the nominal scale is the weakest scale of measurement. Okay, so we can be asked that which of the following is the weakest scale of measurement? It is the nominal scale. So let's look at the properties of the nominal scale. Data categories are mutually exclusive. Okay, so an individual can belong to only one category and have no logical order. So when I ask you of your gender, it's either you are a male or a female. You can be a male and a female at the same time. Gender is mutually exclusive, male or female. Okay, you can be a male and female at the same time. That is why it is mutually exclusive. Okay, and there is no logical order. Okay, if you think male are better than female, then it is your personal view. You can't impose it on the general public that the males are ahead of female. No. Or if you think females are better than male, it is your personal subjective view. Okay, you can't impose it on the general public to accept it. Are you getting it? So there is no logical order. Or when we talk about political party, let's say we have NNN and PPP. Okay, you can't impose it on the general public that NNN is better than PPP or PPP is better than NNN. If you think PPP is better than NNN, it is your personal view. Okay, you can't impose it on the general public. So there is no logical order. So some examples of the nominal scale include classification of 6 colors of candies, let's say to brown, yellow, blue, orange, green, and red. All the candies are the same, just that their colors are different. Okay, and then gender is another example of nominal scale of measurement. So counting men or women, you can only count them that, oh, there are more women than men, or there are more men than women, but you can't rank their value that men are better than women or women are better than men. Individuals may be categorized on the basis of marital status, so according to single, married, divorced, widowed, or others. Okay, so it's also on a nominal scale. Sometimes when you are filling form, you see single, married, divorced, widowed, and others. So you should know that it's on a nominal scale. And then the number of automobile license plates. Okay, so this number GT68009, this is 2009. Now, the fact that it has a number on it doesn't mean you can rank them. They are actually in different categories. Your football jersey, the number on it. Okay, we don't rank the numbers on your football jerseys. No, they are in different categories. And your social security number, okay, your SNIT number is also in different categories. We do not rank them. So now let's look at the ordinal level of measurement. An ordinal scale incorporates the features of a nominal scale, and the additional feature that observations can be ranked, okay, from low to high. So synonym of ordinal scale is ranking scale. So in ordinal scale, only the comparison greater than, less than, or equal to are relevant. Okay, so the equal to relation holds among members of the same class. So let's take for instance, look at this table. We have superior, good, average, poor, and inferior. Here we do not use the frequency to rank it as ordinal. No, what qualifies it as ordinal is the fact that superior is more than good, good is more than average, average is better than poor. We do not use 28 good. No. When we talk about ordinal, we are talking about the qualities, ranking of each quality. Okay, as superior, good, average, poor, and inferior. Some other examples include students' knowledge in business statistics is classified according to levels. Let's say low, average, and high. So we know that high is more than average and average is more than low, isn't it? Yeah. And then the system of grades in the military service, like sergeant, corporal, and private. Then grades according to A, B, C. Okay, you know A is more than B, and B is ahead of what? C, isn't it? And then judging according to first place, second place, third place, and going. Okay, when you judge in that accordance, it's also an ordinal level of what? So now let's look at the properties of the ordinal level of measurement. So the first property is that data categories are also mutually exclusive. Okay, an individual can belong to only one category. You can be average and high at the same time. You can only belong to one. Okay, or you can be in first place and second place at the same time. You can only belong to one. So they are in different categories. And then data categories have logical order. You see, in the nominal scale there is no logical order, but here there is a logical order, because we all know that high is ahead of what? Average. And average is ahead of what? Low. Okay, and so on. Okay, so data categories are scaled according to the amount of a particular characteristic they possess. Now let's look at the next one, known as interval level of measurement. An interval scale incorporates all features of the ordinal level of measurement. Okay, it has all the features of the ordinal level of measurement. What makes this different from the ordinal level of measurement is that the distance between levels on the scales can be specified, or there's a prescribed difference between the ranks. Okay, for instance, let's take temperature. The difference between temperatures of 60 and 70 is the same as the difference between temperature of 20 and 30. Okay, but when you go to the ordinal level of measurement, you do not know the specific difference between high and average, and the specific difference between average and low. So you can't tell whether the differences are the same. Okay, so in the ordinal, you can't tell the specific difference between high and average, or average and low. Now, intelligence quotient, your IQ, the difference between IQ of 130 and 140 is the same as the one between 80 and 90, but it is not so in the ordinal level of measurement, or your SAT scores. Now, let's look at the properties of the interval scale. Now, data categories are also mutually exclusive here. You can have a temperature of 60 and 70 for one thing at the same time. Okay, and also data categories have logical order. Okay, if it is 36 degrees somewhere and 35 degrees somewhere, you can see that temperature of 36 degrees is more than temperature of 30 degrees. Data categories are scaled according to the amount of a particular characteristic that they possess. And then the interval scale requires unit distance, but it is not important which distance is defined to be the unit distance. Now, another property of this is that it has no true zero. Okay, for the interval scale, it has no true zero. For instance, when you have a temperature of 0 degrees, it does not mean an absolute zero, an integer zero. No, it means that the temperature is very low. That's just the meaning. Okay, so it has no true zero, like 0, 1, 2, 3, the actual zero we have. A temperature of 0 does not mean 0. Okay, it doesn't mean the 0 in numbers. Okay, it means the temperature is very low. Okay, so that's what we mean by it has no true zero. Then let's look at the next one, known as the ratio scale of measurement. Now, the ratio scale is the highest level of measurement. So you can be asked that which of the following is the highest scale of measurement. It is the ratio scale of measurement. Okay, it has all the characteristics of the interval level of measurement. And one thing about it is that it has a meaningful zero. So on a ratio scale, 0 means nothing. It means 0. But in interval, 0 does not mean nothing. But in ratio, when you have a 0, it means nothing. Wages. If your wage is 0, it means you earn nothing. Or unit of production. If your unit of production is 0, it means that you produce nothing. Or if weight is 0, it means the thing is weightless. Okay. Money is a good illustration. If you have 0 Ghana cedis, then you have no money. But if you have 0 degrees, it does not mean there is no temperature under interval. Do you get it? The ratio of two numbers is also meaningful. For instance, if Fafa earns 150 Ghana cedis per day for selling phones, and Eva earns 75 Ghana cedis per day for selling wigs, okay, then Fafa earns twice as much as as Eva. The ratio of two numbers here is meaningful. But in interval, the ratio of two numbers is not meaningful. So let's look at the properties of the ratio scale too. Data categories are mutually exclusive and exhaustive. And data categories have logical order. They can be ranked. And then data categories are scaled according to the amount of particular characteristics they possess. The ratios of the values are meaningful. And then the 0 point represents an absence of the characteristics being measured. So when you have 0 Ghana cedis, it means that there is no money. So some other examples of the ratio scale include time, salary, and age. So chapter 1 ends here. If you are new to this channel, please do well to subscribe. So whenever I post the next chapters, you can see them early. Thank you.